This lesson will teach me to simplify polynomials by applying the order of operations. Speaking of order of operations, what do they mean? Order of operations, very often students use the phrase PEMDAS, or please excuse my dear Aunt Sally, to help them remember which one comes first. P standing for parentheses. It's going to be kind of rough here with parentheses because they're everywhere. Exponents, multiplication, and division. Please note that we're not really dividing anywhere, so it's just multiplication, and then adding and subtracting. Looking at problem A, I have addition and I have subtraction. So in this particular problem, we're going to do it from left to right. As I move from left to right, I see addition first, then I see subtraction. Addition, and then subtraction. Over off to the side, I have small examples loaded. If the example were as small as the one shown here, I would add the 5 and the 3, get 8. 8 minus 4, whoopsies, 8 minus 4 is 4. Same concept here, except we have polynomials. So you're going to start by adding these two things. 2x plus x is a 3x. Keep your rules separate. When you multiply like bases, that's when you add the exponents. When you add like terms, you're really adding the coefficients. It starts getting a little confusing. So here I'm combining like terms. 2 of something plus 1 of something is 3 somethings. And I'm going to combine it with a -9 and a +3. That answer now needs to be subtracted from the rest of the problem. 3x minus 5x is a -2x. Negative x minus a -4. -6, I think I said x there. -6 minus a -4 is a -2. Don't want to erase that quite yet. Let's move it over there. Letter B. Gosh, it looks like there's multiplication everywhere. Think about multiplication for a moment. I have an example loaded somewhere. Here it is. If it were this simple, 5 times 3 times -4, you'd probably all grab your calculators, but we can multiply things in any order. 5 times 3 times 4 is the same as 3 times -4 times 5, so the good thing with multiplication is you can mix it around. What looks nicest for you? It really doesn't matter as long as everything gets multiplied, but we can only multiply 2 things at a time. I'm going to start with these two. X times x is x squared, which is that one right there, x times 3. Now I have to multiply that answer by this other piece. So this whole answer here has to get multiplied to the other one. So now it is x squared times x squared times 5, 3x times x, and 3x times 5. See any like terms that can combine? Should end up with x to the 3rd plus, I think I goofed somewhere. Oops, I forgot my squared here. X squared times 5 was a 5x squared, so it's an 8x squared plus 15x. All right, letter C. Again, I don't want to lose that. I think you guys are going to need it. All right, letter C. Order of operations. I see, yes, I understand that there's parenthesis. Yes, there's subtraction inside the parenthesis, but can you subtract x minus 3? No way. So parenthesis doesn't really help here. But there is an exponent, and then there's addition. So the first thing I'm going to do is my exponent. You cannot distribute it here. It doesn't work that way. What that's telling you is that it's x minus 3 times x minus 3. I'm going to go ahead and use my shortcuts because I recognize this as a perfect square trinomial. If you don't like your shortcuts, then you are stuck multiplying. So I get x squared minus 6x plus 9. And don't forget the original plot problem had a plus 5 at the end. All right, letter D. We have parentheses, but I can't combine inside, so that doesn't work. I need to take care of that exponent first. Just like the previous problem, this is a perfect square trinomial. I'm going to use my shortcut. That whole thing is being times, multiplied by 2x squared. Here's some distribution. And again, there's 2 x's here and 1 here, so that's 3. And one more time. All right, 2 more. Letter E. Letter E has multiplication. Yeah, there's parentheses, I can't really combine, and addition. So if we think about, please excuse my dear Aunt Sally, I need to do multiplication. And then addition. Whoops, combine like terms. Last one. Yeah, parentheses everywhere, can't combine, doesn't really help me. Exponents. I need to handle these exponents. I recognize this as a perfect square trinomial. I'm going to kind of rewrite everything and use my shortcut with my perfect square trinomial. So that 3 is really getting multiplied by whatever the answer to this is, x squared minus 4x plus 4. If you don't remember or like the shortcuts, then you're double distributing and combining like terms. All right, next, multiplication. Oops, 12. And because of this plus here, I need to take this answer and add it to that answer. So there's multiplication occurring here as well. I'm going to highlight so you can see like terms. So when I go ahead and combine, this is addition here. Notice where to go. When you're combining like terms, you're adding the coefficients in front. So 3x squared plus 3x squared is 6x squared. That value, I think was a positive 12. Sorry, that got a little messy. So a negative 6x plus a 12 is going to give me a positive 6x plus that 12 out there. All right, I think that's it. Down at the bottom. My next slide. Turn. All right, closure. Closure is kind of a weird concept to get your head wrapped around. It says, closure. A set is closed under an operation, meaning addition, subtraction, multiplication, division, if and only if the operation on 2 elements of the set produces another element of a set. Holy moly. I'm going to keep reading. If an element outside the set is produced, the operation is not closed. What this means, if you take a dog and breed it with a dog, you should end up with a dog, meaning dogs give us dogs. If you take a cat and breed it with a cat, you should get a cat. Guess it's not really worth discussing breeding a cat and a dog because it doesn't work, meaning the set isn't closed. So here's a couple of things to think about. If we were to take whole numbers, what are whole numbers? Whole numbers are 0, 1, 2, 3, so on and so forth. No fractions, no decimals, no negatives. If you were to take a whole number, any whole number, and add it to another whole number, 0 plus 0, 1 plus 1, 2 plus 3, 5 plus 5, would you get, if you were to add any whole numbers, would you get a whole number? Yes. If you were to take two whole numbers and subtract them, 1 minus 2, that's not a whole number. So is it closed for addition? Yes. But is it closed for subtraction? No. A dog and a dog gave me a cat. Closed for multiplication. If you take any two numbers, 2 times 2, 2 times 5, 2 times 3, 2 times 0, will you always get an answer that is whole? So a whole number times another whole number, yeah, it's always going to give you a whole number. So it is closed. Started in the same set, ended in the same set. Division. If you take any whole number and divide it by a whole number, do you get a whole? Sometimes. But what if it looked like this? A whole divided by a whole gave me a fraction. That's a rational number. It's not a whole. So is it closed for division? No. There's nothing right or wrong or good or bad about it being closed. It's just the idea of, is an employer hiring right now? Yes, it's hiring. No, it's not. It's just a state of the way the numbers work out. Rational numbers. Rational numbers are decimals, fractions, and we say fractions. These are those nice fractions. Nope, I take that back. These are the nice decimals. Whoops. I don't like the way that's worded. So these are your nice decimals, your decimals that end, your decimals that repeat, because they're basically fractions. These are zeros, positive numbers, negative numbers, all of that. So if we were to take rational numbers and add them, if you take a fraction and add it to a fraction, you get a fraction. Think for a second, does that always work? Well, if I take a fraction and add it to another fraction, well, I get 0, but 0 is still a rational number. So yes, anytime I add two rational numbers, I'm going to get a rational. A dog and a dog made a dog. Try it for subtraction. Well, we already said 0 was part of that. If I were to do 3/4 minus 1/4, I'd end up with 2/4. Yep, it's a fraction. Yes, a dog minus a dog gave me a dog. Rational numbers subtracted are going to be rational numbers. Multiplication. Try it here as well. Oops, did I just screw that up here? Half and half is a whole. Nah, check out that math. But it's still a rational number. This is going to give me a quarter, but it's still a fraction. Even if I were to do negative numbers, even if I were to take 2, 2 is a positive number, times a fraction, still could be considered a fraction. So yes, it's closed for multiplication. Dog and a dog give a dog. Division, same thing. Grab your calculator and check it. Half divided by half is going to give you a rational number. So again, there's nothing right or wrong about these things being closed or not closed. It's just what they are. Kind of running out of time, so let's think about it. Polynomials, addition. If you were to add any two polynomials, polynomials can be simple, polynomials can be complex. If you were to add any two polynomials, would you end up with a polynomial? Yeah, you would. What if we were to subtract those two things? Would you end up with a polynomials? Yep. Same thing with multiplication. If you were to take any polynomial and multiply it by any polynomial, would you end up with a polynomial? Well, think about the past couple of lessons. We've gotten really big answers and really small answers, but they always ended up being a polynomial. So, bottom line, these are closed under addition, multiplication, and subtraction. We're not talking about division because it makes it harder. Thank you so much for your time. Let me know if you have questions.